Okay, so auto headland on these crazy AB curves. Initiate a curve here. This is without any correction. You see it works perfectly fine when there isn't a lot of overlap. Field like this. Speed up. That works good. Get to a headland or get to a spot where the angle's greater. Way out. That's what, 6 meters off of where it's supposed to turn. So that was the problem Andreas was talking about. Then does that, tries to find the line. Okay, so that's the problem to be solved. Now AB curve is a bit of a complex function as it goes across the field, because the more you are off the general heading from headland to headland you are, the more overlap there's going to be. You can see that as it approaches about 45 degrees here is a substantial amount of overlap. So I don't think you want to use AB curve on something quite as curvy as this. But you can see in little areas here where there's a lot of overlap, and then here it's just right, and then lots of overlap again. Now the problem is with that turn that Andreas was pointing out is that this distance is no longer the equipment distance, because there's a lot of overlap. That slack's got to be taken up somewhere. If you did contour, then of course it'd keep getting sharper. So how do we deal with the generating of a Dubins or a pattern that compensates for this amount of overlap, or this not amount of overlap, or a bit of overlap, that sort of thing? So I got to thinking. I've enabled the bounding boxes. This is the one for U-turn, and then this is the one that picks up the point on the reference line and then determine how many implement widths over. So I got to looking at this, and you can see that if it's a straight line, these should make a T. They should be perpendicular. So what I do is this formula. What it does is it takes the average line heading and subtracts from the reference line heading, and they should both be 0 when this is done. And if it's, then that becomes the delta of the reference and the average heading. So that is this is the average heading line, and then the line you're on here is the heading of the reference line. Now if it was a straight line, the reference and the average heading should be at 90 degrees. And so then then what good does that do? If we take the cosine of it, and if that average reference and average heading subtracted is 0, cosine of the heading is 1. And then as that changes, as that becomes greater than 0, then we multiply. We go over here to U-turn where that curve is generated, and we just multiply the delta that's created, the cosine of the difference between the reference and the heading. Whew. And then that then becomes our turn offset. So the greater the angle it is, the less the delta is, therefore the narrower the implement is. And it works. There you can see it's perpendicular, lines up good. So then if we do it here, it's pretty close. It works not too bad. So that works pretty good, even though there's a lot of overlap. If you're going around a sharp corner, then it picks up the wrong heading, because then that ideally should be the right heading, but it's still pretty close. As long as the line is fairly straight, as long as you're not trying to turn on a 45-degree corner, it's pretty good. If we do one here, might be a little off. Yeah, see, it's just a little bit off. Here you can see the delta down here. Pretty close though. I mean, before it was like half a width off. And I'll just let it do an auto turn. So it works good.